Everybody, this is Toby Delbrook, Institute of Neuroinformatics Sensors Group, University of Zurich, ETH Zurich. In this demonstration or tutorial, I'm going to show you how to use an event filter called Oscilloscope, which we developed to do real-time debugging of event sensor parameter tuning. So to show you how that is, I'm going to run from the development branch of jAER in NetBeans, and I'm using a DVS 240C camera here, which is plugged in. So you see it looking around DVS events, frames, IMU, and so on. In this demonstration, I'm going to show you how to set up better, higher bandwidth properties of the DVS pixels. Now, normally these are controlled using the bias generator control panel. And if you're a novice user, you probably want to use these user-friendly controls, as described in a previous tutorial video, to adjust the pixel bandwidth, event threshold, refractory period, and so on. Here I'm going to show you how to use a new filter developed maybe about a year ago called Oscilloscope. You can get at it by going to the filter frame and then doing select filters and then typing Oscilloscope, double-clicking it, so that it gets added to the list of selected classes, and that'll add it to this list of filters. Let's expose the controls for it. What Oscilloscope does is replay parts of the live output. Just like an oscilloscope shows you traces of an electronic signal, this is a filter which records the data from the sensor and plays it back live in slow motion for you, so you can see what's going on with it. It's kind of a complex control, like most oscilloscopes. It allows you to set the capture type to be time interval or event number. So how long should the oscilloscope capture, or how many events should it capture? How it should play back the events. Should it play back by constant time interval or constant event number, where you can set the number of events that are played back, the number of cycles that it plays back the video, or the time interval. So either event number or time interval. And it allows you also to set multiple trigger sources for this oscilloscope. So you can trigger auto with some trigger interval, or you can trigger on bias changes, time interval, event interval, manual triggering using this button up here, and so on. So you need to play around with this and see what's going on. So let's switch to the different color mode of the sensor here, red and green, where off is represented by red and green by on events, and use our friend here, SpongeBob, with the little spinning dot, to explore how to set up maximum bandwidth, pixel bandwidth, without maximum noise on this DVS output of the DVS. So normally when you play it like that, you can see the spinning disk. In order to optimize the parameters, you would have to record some data and then play it back in slow motion, change the parameters. The oscilloscope allows you to do this live. So I'll turn on the oscilloscope and show you how that works. Right now it's set up for bias change, and it's set up to play back 500 microseconds per rendered frame, and it's set to trigger on each bias change. So as soon as I touch the bias change here, you see how it plays back in slow motion, this short interval. Every time I touch this bias change here, it's going to play back a short segment of the recording. So as I reduce the pixel bandwidth below the nominal setting, you see how the disk here becomes more and more blurred out because the pixel photoreceptor becomes slower and slower. You see how it's really blurred out? Now I'll increase the bandwidth, moving it to the right so that it's above the nominal setting. And what you should see is that the dot on this disk becomes more and more localized every time I do that. You see that happening maybe? I'll go to really high bandwidth. And now if you want to explore that more carefully and you don't want to trigger it every time you go to trigger mode auto, and it will just keep playing back a little piece of the data over and over again. It'll record a little segment and then play it back once, record it. If you want to change the time interval on that, so you see less events, you can change this time here. And now you see the dot is actually very well localized. Now another thing you can see is when you do that here, when you go back to normal playback mode, so it's not replaying the data, you'll probably see that the sensor actually gets also very noisy here. That's because we've increased the bandwidth a lot. So when the pixels are dark, like on my dark sweater here, you get a lot of noise. Now you can adjust that by increasing the threshold here. Now you get rid of that background noise. Now does it still see the dot? Well, the threshold background noise is quite low, but does it still see the spinning dot? Well, to see that, go back to auto trigger mode. So you're playing back, and now you get a nice, well isolated dot with a clean leading and trailing edge. Now the trailing edge does still have resonance. You see this extra ringing at the edge, at the trailing edge? That's probably because the photoreceptor or the differentiator circuit in the pixel is ringing a bit. It causes an extra on event at the trailing edge. And you can now explore using other controls how you might reduce that resonant ringing. So I hope this tutorial is useful to help you do real-time tuning of DVS pixel behavior.